Hello students, it's time for math homework. Are you ready for some math homework? I hope so. And this is 8th grade math, Unit 4, Lesson 4.2. 8.4.2 means 8th grade math, Unit 4, Lesson 2. And we are working on balancing equations. And you can see this with balanced hangers. Question number 1. Which hanger is in balance? Okay, circle your answer. And you can see the hanger that is in balance, meaning both sides are equal. Okay, for hanger A, you see that there are 3 triangles on the left side and 1 triangle on the right side, so that is not in balance. Let's say that each triangle were x. Then we have 3x on the left side and 1x on the right side. We could write an equation like 3x and 1x, but that is not equal. For B, we have 3x on the left side and 3x on the right side. That is balanced. For C, we have 1x on the left side and 3x on the right side. It is not equal. That is not balanced. All right, good job, guys. Let's keep going. Look at problem number 2. Problem number 2 says, which of the changes would keep the hanger in balance? Select all that apply. Okay, well, even before I start, the first thing I notice about this hanger is that I could subtract a triangle from each side and it would still be in balance. If I subtract a triangle from the left side and from the right side, it's still in balance because I subtracted the same thing from each side. Let me write that as an equation. Let's pretend that the squares are equal to x, and let's say triangles are z, and the circle will be y. Now, if I write an equation with this hanger, looking at the left side, it's x plus z, and I got that from here, x plus z equals 2y plus z. Now this is a really important part of this lesson. You can subtract equal quantities from the left and right side and an equation stays in balance. So that's what I meant by subtract a triangle from the left side and subtract a triangle from the right side. If I call the triangle z, then I subtract z from the left side and subtract z from the right side. And what you're going to see in algebra is if you do it to one side, you have to do it to the other side, and that stays in balance. So my equation becomes x equals 2y. That shows me that 1 square is equal to 2 circles. Remember, I subtracted these triangles off. So now I see that 1 square equals 2 circles. Okay, now let's check these out. Adding 2 circles on the left and a square on the right. Adding 2 circles on the left and a square on the right. Well, hold on. Okay, so I'll draw that on. 2 circles, 1, 2, and a square on the right. Here's my square. So does that stay in balance? Well, yes, it does, because I already saw that 1 square equals 2 circles. When I subtracted these triangles, I see that 1 square equals 2 circles. So if I add a square on this side and 2 circles on the other side, that's still in balance because 1 square equals 2 circles. So A is still in balance. Okay, B. adding 2 triangles to each side. Oh, well, I think that makes sense that if I add 2 triangles on the left side and add 2 triangles on the right side, yes, that's still in balance. If I add the same weight to each side, it's still in balance, yes. C, adding 2 circles on the right and a square on the left. Well, I already saw that 1 square equals 2 circles. So if I add 2 circles on the right and 1 square on the left, yes, that is the same weight added to each side. That stays in balance. Adding a circle on the left and a square on the right. Let's see, a circle on the left and a square on the right. No, those are not equal. It will not be in balance. Adding 2 triangles on the left and a square on the right. Are those equal weights? No, we can't see that from what we have. So no, we don't know that those are equal weights. It doesn't look like that from our diagram. We're not sure what the triangle weighs, but those are not equal weights as far as we know. Let's keep going. All right, you guys are doing great. All right, number 3 is kind of a long one. Here is a balanced hanger diagram. And the problem says each triangle weighs 2.5 pounds. Let me just write that down. 2.5 pounds. Each circle weighs 3 pounds. You know what? That circle kind of looks like a 0. I want to be careful. Circle weighs 3 pounds. I wrote a P for pound. That's my mistake. LB is the proper notation for pound. Let me change that. LB, pounds. And X represents the weight of each square. So square equals X. Select all equations that represent the hanger. Okay. So that's why I showed you before making equations with your hangers, because that's what we're really learning to do, is look at balanced hangers as equations. If each square equals an X, then you can just go ahead and put X, 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 X to help you. And then each triangle equals 2.5, okay, 2.5, 2.5, 2.5, and a circle equals 3 pounds. So just put in 3's next to everything. Does this help you see it as the values that they hold? Now let's write that as an equation. We have x, 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 x plus x plus x plus x plus 2.5 plus 2.5 plus 3, all of that is on the left side, equals x plus 2.5 plus 3 plus 3 plus 3. That's on the right side. So we have left side equals right side. And we know the left side equals the right side because our hanger is in balance. So this is a balanced equation. Now select all equations that represent the hanger. Well, we can do things to this equation to simplify it. We can combine like terms. I want you to listen to that again. Combine like terms. And what that means is you get all of the x's together and you get all of the whole numbers together. All of the rational numbers together. Not necessarily whole numbers because I have decimal points. Anyway, so let's do that. Let's combine these 4 x's and combine these 2 x's and combine these numbers on the left and right side. What we get is 4x on the left side plus 2.5 plus 2.5 is 10 plus 3, that is 16. Oh, I'm sorry. Not 10. I'm sorry. 2.5 plus 2.5 is not 10. 5. 5 plus 6, let me circle this so I'm not confusing myself. This is equal to 5, this is equal to 6, and that is equal to 11. So on the left side of my equation, I have 4x plus 11. And then write your equal sign again. And then look at the right side, we have 2x plus 2.5 plus 9. This is equal to 9. 9 plus 2.5 is 11.5. You better check my math. You know I make mistakes. So I went from this long equation to a more simplified equation where I combined like terms on the left side and on the right side. Well, I can simplify this even more. I can subtract some quantity from each side of the equation to simplify it even more. So I want to combine this 11 and 11.5. Here's what I can do. Subtract 11 from the left side and subtract 11 from the right side. Now I'll write my equation again. I get 4x equals, now 11 minus 11, that's 0. 2x, just bring that down. And then 11.5 minus 11, that equals 0.5. When I combine these terms, I get just another 0.5. So I went from this equation, and it is equal to this equation, and it is equal to this equation. I'm going to go one step further. I'm not done. Now, this 2x and this 4x, I can combine those like terms. I'm going to subtract 2x from the right side and subtract 2x from the left side. And then I'll write my simplified equation. 4x minus 2x, that is 2x. Bring down your equal sign here. 2x minus 2x equals 0x. It just kind of goes away. It cancels out. So I'm left with this 0.5. So that's another equation. Here where I have equation 1, 2, 3, 4, they are all equivalent equations. I can subtract things. I can subtract equal amounts from the left and right side, and my equation stays balanced. Let me show you what that looks like with the hanger. Imagine, or just look and see, if I subtract these two circles on the left, then I have to subtract these two circles on the right to keep it balanced. And I can subtract this triangle and one more triangle here. If I subtract one triangle from each side, that is an equal amount, so it stays balanced. I can also subtract two squares from each side, and my hanger stays in balance. So just like the equation, what you do on one side, you have to do on the other side to stay in balance. Okay, now on your own, look at A, B, C, D, and E. Which one of these, which three of them are equal to the original equation? So now it's your turn. Go with your pen and paper and write the original equation and then combine like terms and see if you can get 3 of these equations. I've showed you 4 of them. Let's keep going. Make sure that you are pausing the video and taking notes on your own. Okay, number 4. Choose the most simplified equation that represents this hanger. Now it says most simplified. Remember, I can simplify an equation by subtracting equal amounts from both the left and right side. So for this hanger, I'm going to call a square X and a triangle Y. Then I have 3x on the left side, and that is equal to x plus 4y on the right side. 3x on the left side and x plus 4y on the right side. Now I can simplify this by subtracting an x from each side. 3x minus x gives me 2x. And that is equal to x minus x is equal to 0, so that cancels out. So that's equal to just 4y. Now looking at the equation, you can see that is true. I can subtract an x from the right side and an x from the left side, and I get 2x equals 4y. So you can see that's true. Now, guess what we can also do? Not only can we subtract equal quantities from both sides, we can divide both sides by the same number to simplify even more. 2 and 4 are both divisible by 2. So I'm going to divide the left side by 2, and I'm going to divide the right side by 2. 2 divided by 2 equals 1. So that's 1x equals 4 divided by 2 is equal to 2. So I get 2y. For the number 1 here, when you see a number in front of a variable, it's called a coefficient. The coefficient of 1 does not need to be written. We can just simply say x. X equals 2y. Now we have the most simplified equation. I want you to follow along and do these steps on your paper. If you're not following along with pencil and paper ready, it's going to be really hard as we get to harder and harder math. So please practice on your own. Okay, try number 5. Number 5 says, what is the weight of a square if a triangle weighs 4 grams? Okay, remember we can subtract a square from each side to help us simplify our equation. And we get, let's call the squares x, let's call the triangles, they're 4 grams. So we get 2x equals 12 grams. Now you can do the math here. What is the weight of a square? Well, I'm going to do this as a tape diagram. X plus x equals 12. So what must the x be? Good. Go ahead and do that math. Now, I've showed you how to do this with a tape diagram in the previous lesson, but now I'm going to show you an even easier way that's going to help you as the problems get harder and harder. I put the G for grams, but let's get rid of the units for a second. 2x equals 12. Remember I said you could divide both sides by the same number? So I'm going to divide this equation here by 2. Divide each side by 2. 2 divided by 2 is equal to 1. So we have just x. The coefficient is 1. But remember I said you don't need to write the 1 before the x. And 12 divided by 2 is equal to 6. So what I get is x equals 6. And that is a faster way to solve the problem rather than making those tape diagrams. As our math gets harder and harder, you're going to want to just solve it this way, dividing each side by 2. Let's keep going. Okay, number 6. A circle equals x, a triangle equals y, and a square equals z. Write a simplified equation for this hanger. Hint, you can subtract one square and one circle from each side. And there is only one correct answer that is simplified. Okay, here are your choices. you can subtract one square and one circle from each side. Okay, let's do that. So from the left side, subtract one square, and from the right side, subtract one square. From the left side, subtract one circle, and from the right side, subtract one circle. And then we get, it says x equals circle, so let's just fill that in, x, x. Y equals triangle, okay, there's a y. And z equals square. Now let's write our equation. Sorry, I was off camera, but that's okay. You can follow me still, right? Okay, y. On the left side, we have y plus 2x. See here, y plus 2x equals 1, 2, 3, 4 z's. Okay, there we go. Here's an equation that represents this hanger. Let's keep going. Number 7. A circle weighs half a gram. A triangle weighs 2 grams. How much does each square weigh? Oh, this is going to be difficult because it's such a long balanced hanger. Okay, if a circle weighs half a gram, then let's count up circles. I'll put a 0.5 next to it. Half a gram, half a gram, half a gram. Here's another half a gram, half a gram. Okay? Triangle weighs 2 grams. 2, 2, 2, 2, 2, 2, 2. How much does each square weigh? Let's call the squares x. X, 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 x. Now before I write this equation, can I simplify it? I think it's too confusing for me to simplify by looking at it. I'm just going to write it out. Okay, so for triangles, I'm going to circle them as I count them. I don't want to make a mistake. 1, 2, 2 triangles on the left. So that's 2 times 2 grams. And then count the circles. 1, 2, 3 circles. So plus 3 times 1/2. And then count x. 1, 2, 3, 4, 5, 6. Plus 6x, and that is equal to, on the right side, let me count triangles. 1, 2, 3, 4, 5 triangles. So 5 times 2 grams plus, count the circles. 1, 2. 2 times 0.5 plus, count x's. 1, 2, 3 plus 3x. Now I need to simplify this equation, so I'm going to do the math. Look at each term. This is a term, this is a term, this is a term. These are called terms, and they're separated by a plus or minus sign. Look at each term and do the math. 2 times 2 equals 4. 3 times 0.5, that equals 1.5. 6x, there's nothing I can do with that yet. 5 times 2 equals 10. 2 times 0.5 equals 1. And then the 3x, there's nothing I can do with that yet. Now I can combine these like terms. So on the left side of my equation, I have 4 plus 1.5. I'm going to write that down here. That's 5.5. Plus this 6x still stays. And on the right side of the equation, 10 plus 1 equals 11 plus 3x. Phew! Remember, I'm trying to solve for x, the weight of the square. Let's keep going. I need to combine these like terms, 5.5 and 11. Here's what I'll do. I will subtract 5.5 from each side. Then this 5.5 minus 5.5 equals 0. And the left side is left with only 6x, and that equals 11 minus 5.5, which is equal to 5.5. 11 minus 5.5 equals 5.5. So the 6x comes down here. 11 minus 5.5 is 5.5. Plus the 3x comes down here. So I have 6x's equals 5.5 plus 3x's. Okay, let me subtract 3x's from the right side. So I'll do the same thing to the left side. I'm subtracting 3x's from the left and right side. If you subtract the same weight from both sides, it stays in balance. 3x minus 3x equals 0. So that goes away. On the left side, I'll have 6x minus 3x, and that equals 3x. Equal sign, and then my 5.5 comes down. And what I'm left with is 3 times x equals 5.5. All right, the last thing I can do is divide each side by 3. And when I divide each side by 3, then I get 3 divided by 3, that equals 1. So I just have x on the left side. X equals 5.5 divided by 3. 5.5 divided by 3. Do you remember how to divide these numbers? Looks like I'm out of paper. I'm going to let you do the math to see what x equals, okay? I'm out of paper. You'll have to do the math. Oh, okay, I'll do it a little bit. This is a mixed number. Let's turn that into a fraction. 5 times 2 is 10 plus 1, so 5.5 equals 11 over 2. And we're going to divide that by 3. So what you'll end up doing is multiplying it by 1/3, and that equals 11 over 6. Okay, you're going to have to check the math on your own and select the correct answer.